Welcome to today's Energy Central Power session entitled Reconductoring with Advanced Conductors. Now I'd like to turn the floor over to the moderator of today's event, Mike Beehler, COO of Mike Beehler and Associates, to kick things off. Mike, welcome to the event. You have the floor.
Thank you very much, PJ. I appreciate that. And thank you for joining us today. This is going to be a great topic, very timely topic, and we have some outstanding guests with us today. So why is this an important topic right now? We know in our industry that transmission in particular is very difficult to build. We look at big projects that don't get permitted, they don't get routed and permitted. We look at really big projects that need to bring renewables to load centers that take years, if not decades, to get permitted. So a mega trend, I believe, in this industry is that we need more capacity out of existing transmission corridors, out of existing rights of way. And in fact, that's what this is all about today. Reconductoring with advanced conductors is about that very thing, getting more capacity out of existing rights of way. We have an outstanding group with us today. James Berger from AEP, Devon, Kendall from Nevada Energy, and Dave Bryant from our sponsor today, CTC Global. So we'll ask each of these gentlemen to say hello to us briefly. You can certainly read about their backgrounds if you'd like. We'll get a quick greeting from each of them, and then we'll go into a presentation. Dave will start off and give a little bit of a technical presentation, and we'll get towards the end with about the last half of this. Great time for questions. Be thinking of your questions. Go ahead and send those questions into PJ straight away. And this is meant to be a conversation, so if you've got questions, send them on, and we'll see if we can't weave them into the conversation. But James Berger from AEP, longtime friend in the industry, give us, say hello to the audience and give us a greeting if you would.
Hey, yeah, thanks, Mike. It's great to be with you today and work with you again. So I'm James Berger, Managing Director for Transmission Engineering, American Electric Power. I've been with AEP for 40 years, so I appreciate you guys showing a much younger me on the headshot there. So with that, I'll turn it back to you.
Thanks, James. That is a good-looking picture of you. Devon Kendall at NV Energy. Great to have you today. I know you've got some really exciting things to say about the things that you're doing at NV Energy. Give us a word of greeting, Devon.
Hi, Mike. Thanks for having me today. Devon Kendall. I'm the Civil and Transmission Engineering Manager at NV Energy. I have about 8 years of experience in transmission engineering, and I love using the ACCC conductor and have had lots of experience with it. So I'm happy to share that experience with all of you today.
We appreciate that. We know you got some great slides to show us here. Dave Bryant, you are our technical subject matter expert. You're from CTC Global, decades of experience in the industry. Say a couple of words of greeting for us, Dave Bryant.
Thanks, Mike, and thanks, James and Devon and everybody at Energy Central that have been helping us out. I'm proud to have been with CTC Global since its inception about 21 years ago when this picture was taken. James, I can relate. I look forward to a lively discussion and hope that we get to as many questions as everyone has time to submit. Thank you.
Thanks, Dave. We appreciate it. So again, got a great panel of experts here. We're going to hear some outstanding stories, lessons learned, best practices from utility users of advanced conductors. But we're going to start off with Dave Bryant to give us a little bit of a technical background on advanced conductors. So Dave, take it away.
Thanks. So the need to increase the capacity of existing corridors isn't really new. If we look back to the 70s, in fact, we developed, the ACSR conductor has been around for over 100 years, and to increase the capacity, ACSS conductor was developed to be able to handle more capacity, and was used widely for reconductoring projects or rebuild projects. Over the next couple of decades, INVAR conductor was introduced. It's also a high capacity or HTLS type of conductor. GAP conductor followed. And then in the early 2000s, the advent of composite core conductors, which now we refer to as advanced conductors, they landed on the scene. And we can see that there's a metal matrix design that was provided by 3M here in the United States, fairly well accepted by a lot of utilities. And then a number of composite core conductors have evolved, including ACCC, which is what we focus on. And the benefits are the fact that carbon fiber is a lot stronger than steel. It's a lot lighter, The lighter weight allows us to include about 30% more conductive aluminum, which not only helps increase capacity, it also makes the conductor more efficient. It lowers the electrical resistance, reduces line losses. And again, having twice the capacity isn't something that people necessarily do on a daily basis, but having the added capacity can not only help you link renewable generation resources, it also can help you with resolving N-1 conditions where you can reroute power. So we're going to get into a little bit more of that momentarily. I guess the bottom line here is, as it's highlighted in green, is that these types of conductors are ideally suited for reconductoring projects when you need the added capacity, and sag reductions are critical. Thank you. Next slide. So as I mentioned, some of the benefits, but again, really, the biggest thing is that reconductoring allows you to very quickly and cost effectively go in and increase the capacity of an existing transmission line. This can help relieve grid congestion and bottlenecks, which allows utilities and consumers to access the least expensive and cleanest sources of generation, which is really important. I mean, without access to affordable and reliable electricity, no business entity or society can really be competitive in a global economy. So it's really important that we deliver reliable and affordable energy, and using the existing grid is the fastest and least expensive way to get there.
Hey, Dave, this is Mike. I'm going to comment on that real quick. I do agree 100% that electric energy, but electric energy in particular is the foundation of any economy. I wanted to ask about these pictures here. Are these pictures actual work that you guys have done with CTC Global? Is this are these EHV lines that are here in domestically, or maybe even over the world? Because I know you guys are an international company as well.
The picture on the left is actually a water crossing in Malaysia. This was a 48 or 50 kilometer tie line to a new generation facility. So they selected ACCC conductor actually for a new line in that case. And then the picture on the right was in National Grid UK, upgraded the capacity of a transmission line to an existing generation plant as it grew. So they're looking for improved efficiency and greater capacity.
Good, thank you.
We can go to the next slide. If you guys were around back in 2003, you remember there was a major blackout in the East Coast. And while that blackout was triggered by incorrectly calibrated telemetry devices, poor communication between grid operators, computer reboot failures, at the end of the day, excessive conductor sag caused a sag tripping outage that took out the entire Northeast grid. And so this is about the time that CTC commercialized the ACCC conductor. And you can see by these pictures, both of which were actually taken in the UK, show a difference in the sag between a conventional ACSR conductor and an ACCC conductor. And these were also double circuit lines, running the same amount of energy. So the sag mitigation factor offers a tremendous amount of benefit. It helps improve clearances to vegetation to reduce fire risk. It helps improve reliability, and it supports added capacity. As conductors typically carry higher levels of current, the materials heat up, and that can cause sag. So by moving from a steel core conductor, a metal-based conductor core, to a composite core, you've got a much improved coefficient of thermal expansion. That helps mitigate sag. It also, in some cases, will allow you, like a new line, it'll allow you to reduce the number of structures required for any project, which can lower, lower timeframes for construction. It also can reduce structure height. So if you're in an environmentally sensitive area or in a place where people don't want to look at a lot of tall towers, you can reduce that. And even recently, the Audubon Society recognized that fewer structures is actually healthier for birds. So there are a lot of ways to look at this, but reduced sag is a key component of advanced conductors. Next slide.
Dave, that's actually a very good recap of some of the advantages. It sounds like maybe CTC Global needs to write a white paper on that, because there's a lot of really good advantages there.
We've got a pretty good library of white papers, and what we're trying to do now is better understand utility needs so that we can help them recognize the the benefits, not just of added capacity and reduced sag, but there's so many other benefits that can be recognized. And I'll get to those in a couple of slides. But this slide in particular, this goes back to about 2005. This was testing done by Kinectrics lab by Hydro One. They wanted to compare how different conductors that were available at that time compared to ACSR conductor. And in this case, you can see the ACSR conductor that would normally be limited to operating at around 100 degrees C would have a sag characteristic and clearance associated with that line reflected by the grid, the X and Y axis here. And the area that's sort of yellowed out shows that even though other HTLS conductors were designed to carry twice the amperage, that many of them sagged out before they actually met their actual goal. So, and I've known and worked with a number of utilities that installed ACSS conductor 1 or 2 decades ago that found that they had to actually go back and either raise the structures or replace a conductor because the sag was greater than they thought. And so these modern conductors, ACCC in particular, not only reduces that sag, but it also operates at much cooler temperature because it's got additional aluminum content and higher quality aluminum. So you get the benefit of reduced sag. You also get the benefit of being able to carry much more current when you need to, whether it's once an hour every day or for several hours during any time frame. That added capacity helps, but the improved efficiency is another key component of this technology. And again, advanced conductors are really ideally suited for reconductoring projects. Thank you. Next slide. Okay, this is sort of a summary of the benefits. You can get about 50 to 100% more capacity if you're swapping out a double AC or triple AC conductor. The capacity might even be closer to 3x rather than 2x. But nevertheless, the benefits of having more capacity are very important, especially in today's world. The reduction in line losses also is very helpful. And these types of projects can be done at about half the price or less than half the price of conventional rebuilding projects. And I think Devon and James are going to be talking about that here in a few minutes. It's also interesting that when you go to a group like California Public Utility Commission with a project proposal, sometimes rebuild projects they take a long time, they can require long outages, and they're very expensive. So when SCE, for instance, went back and said, hey, we could do a reconductor project for about maybe 1/5 of the cost of a rebuild project, they were pretty giggled up, and their project was approved that day. That was a Big Creek corridor project. So it's a very quick way to increase the capacity of existing transmission corridors. Very important. And reducing permitting the process is very, very good. And these projects are typically performed under maintenance category. So it's a lot less arduous getting permission to do these types of things.
Dave, I'm going to comment too. I think one of the things that many utilities across the country are facing is they've got these data centers that are coming in, and these data centers need a couple 100, 300 megawatts of power, and they are going to be located in urban areas or at least suburban areas. And how do you get a new transmission line in to feed that load? And the answer is you don't, not in a short amount of time, not in the amount of time it takes to build a data center. So here's a way to go get a conductor to reconductor an existing corridor to upgrade the capacity of that corridor to maybe serve something like a data center. And we're seeing more and more of that. I saw that Arizona Public Service, for example, was talking about the load growth that they've got coming in the coming decade. And it is driven by electrification and electric vehicles and data centers. So this is a great tool. It's a great technology to be able to use to do things much, much faster than we might normally do with regular transmission lines.
Thanks, Mike. Very true. And I think that I don't think many of us envisioned data centers requiring so much energy 10 years ago. So there's a lot of dynamic, exciting things that are going on in our industry, and this technology is really helping a lot of utilities resolve their problems. Thank you. Next slide. I think when most transmission engineers and managers first look at their project, they typically have capacity constraints, or they have concerns about sag infractions. There are other things that are considered as primary project objectives. But when you actually look at the benefits of having improved efficiency, it's remarkable. I mean, people buy transformers. They might be a little bit more expensive, but they buy them because they have a better life cycle cost. They last longer. You pay a little bit more, but you get a lot more out of them, and they last a lot longer. And so these types of things also should be considered with modern conductors or advanced conductors. And I know that Devon and James are going to talk a little bit more specifically about the benefits that they've received from these things. But I think, generally speaking, utilities need to, and policymakers, they need to understand that the technology investment is helping on many, many levels beyond just dealing with sag infractions. So there's a lot here. Even things as that you wouldn't normally think about, but typical thermal power plant uses about 12,000 gallons of water for cooling purposes, converted to steam. And being able to reduce fuel consumption and associated emissions and conserve water is a big deal. I remember about 10 years ago, we had a visitor from Malaysia come in, and I was doing one of my typical technical presentations, and he had been on the airplane for 20 hours, and I talked to him about higher capacity, reduced sag, and then when I mentioned the fact that this also reduced line losses, frees up generation capacity that's otherwise wasted, this man lit up because he had a problem delivering power. So when he realized that he could free up generation that was otherwise supporting line losses, it was a big hit for him. And so if you can look at these new technologies with a broader mindset, I think you'll recognize that there are a lot of things that can be used to help your project and your business succeed. It's a pretty highly competitive world.
Well, Dave, I'm going to comment on this too, and I don't want to interject too many times here, but this is exactly what we as an industry need to look at. We need to look at the total cost of an asset over the life of the asset, and looking at all of these various parameters is very important in that evaluation. I think today's planner and engineer and data analyst, I'll even say there's enough data on a lot of the things that we do in the industry now. Actually, I was on a panel a month or so ago, and somebody said, we go to our data analysts before we go to our planners and engineers. What does the data tell us? And the data over the life of the asset, or as we project over the life of the asset, is extremely important. And I'll say my last comment would be, what is FERC 881 all about? 881, which we're going to have to be compliant with here next summer, and James and Devon, you can comment on this later, is all about getting more capacity out of existing transmission lines by getting the actual ambient air temperature. No longer do we speculate or theorize what air temperature is. We have actual ambient air temperature, allowing more capacity out of transmission lines, which is exactly what we're talking about with advanced conductors. So back to you, Dave.
One last comment on this slide. There's a lot of things going on here. Kind of apologize for that, but if you look at the box in the upper right corner, it talks about that annually we're reducing CO2 emissions by about 4 million plus metric tons, and that's the equivalent of removing nearly 1 million cars from the road. If you think about removing the cars and the smog equivalent or the energy required, these numbers they're just absolutely remarkable. Can you imagine, for instance, the cost of buying 1 million electric cars? My calculator won't give me a number that's that high. So, and all of this stuff just comes as an added bonus. It's not even factored into the cost of doing a rebuild. These are benefits to society and to the environment that really shouldn't be ignored. Thanks. I'm going to move on to the next slide. Kind of a closing thought for me is that many utilities have kind of a conservative attitude about new technologies. I think now that's changing. I think we're taking our challenges a little bit more seriously, and there's so many new technologies that are finding homes in this quadrant of project types. But I think one of the most important things about the carbon fiber hybrids and why you'll see so many other people develop these technologies is because they really have great attributes that help with longevity. They resist cyclic load fatigue and corrosion much more effectively than steel cores. I've had utilities talk about ACSR conductors, or they call it all aluminum steel core, or all aluminum no core conductors. They had such problems with corrosion in agricultural areas and coastal environments with salt air, or in industrial environments, or there's this corrosion is such a problem. So being able to improve resistance to fatigue and corrosion and improve the longevity helps reduce life cycle costs. And it's really a great solution, which is why we're seeing it deployed so widely these days. Thank you. Next slide. This is sort of the CTC scorecard. We've completed over 1,100 projects in 65 countries. That represents about 170,000 kilometers of wire installed. And the experience that we've gained, not only in all the different countries, but also in the environments. There's so many, difficult things and challenges that you deal with. Every project's got its own unique challenges, and to have so many qualified installation crew members that are out there supporting our utilities is a really big plus, and that's also helping ease the challenge of leveraging new technologies. And in the bottom left corner, I think it's pretty surprising for people that aren't familiar with what we're doing, but we get updates every 2 weeks. We currently have 80 active projects. 11 were completed last month, and there are 138 ACCC installations that are scheduled for the next few months to get started. So there's really a lot of action around the world and a lot of experience that we can share with our customers. Thank you. Next slide.
Well, I'll tell you what, Dave, that's a great overview. We're getting ready to, James, to transition to you and your story at AEP. Dave, Bryant, I've just got one last question for you. You just showed that slide with all the projects that you have and the ones that you've done, 170,000 kilometers of work. Where are your plants? Where do you make this ACC? Domestically here in the U.S. or overseas? Where are the plants?
Thanks. Our number one facility is here in Irvine, California, in the West Coast. We've got a plant in China. We've got a plant in Indonesia. We have a plant in South America, and we're about ready to open a plant in India. So we've got a lot of capacity, a lot of experience, and a very talented group of people. Thank you.
Good. Well, I'm glad to hear that you're opening a new plant in India, because I'm thinking as I'm listening to this that this is going to be an answer for a lot of things that we face in the industry. We set a lot of goals about achieving renewable goals and net zero energy goals and building transmission to deliver renewables to load. And we're going to need more capacity out of existing corridors. Okay, so now we're going to transition, audience. We're going to transition over to a couple of utilities that have done some stellar work in this, and they've got great lessons learned. They've got some best practices. They've got the stories to tell. So James Berger at American Electric Power, take it away.
Hey, yeah, thanks, Mike. Before I get started and talk about our journey into these high temperature, low sag conductors, I want to reinforce something that Dave mentioned about utilities being conservative. When I started in the industry 40 years ago, it seemed like you would get a new technology, you'd study it for 5 to 6 years, and then you'd do a pilot, and you'd have to let it be out there for about another 10 years before you got comfortable with it. And I have to agree that utilities can no longer take that kind of time to try new technologies. And in this case, this is not really a new technology anymore. It's been around for 15 plus years, and so it's becoming more mainstream. But that being said, let me talk a little bit about AEP. So AEP, we pride ourselves as an engineering company, and we have a long history of industry firsts, and it's evidenced by our 2,100 miles of 765 kV, and that is the most that's in the United States for sure. We have 40,000 miles of transmission. I think we are the largest transmission owner in the United States as well, and that covers in 11 different states that we do that in. So we have a long history of transmission excellence, and so our strategy really is always look for those technologies, take the diligence to make sure that it's reliable and operational and safe and all those types of things, and then try to put it into use. So, and obviously we do that and relate it to advanced conductors for the same reasons that Dave was mentioning. We have more and more are having issues trying to get outages. And I'll use as an example in Texas, where we serve quite a large area. There's a moratorium on outages in the summer months, basically from May until September. And so you can't really do any planned outages. So it really pushes a lot of construction into a shorter and shorter window, which means that you've got to do things faster than you've done before. And that means that your clearances have to be less or less duration than they used to be. And same time, we have growth areas. I know Mike mentioned the data centers that are coming in. We have at least 3 or 4 areas in our service territory where those data centers, you know, we're not talking megawatts anymore. We're talking gigawatts of area of load that's coming into these areas. And obviously with constrained right-of-ways, the more you can put through them to get to those load centers, the better. So obviously there's that pressure about trying to obtain new rights of way is getting more and more pressure than it is to expand the capacity of the existing rights of way. So if you move to the next slide, please. So why did we look at new conductor technologies? I have to laugh. I had a boss one time that when I was telling him about you know, the advanced conductors, he goes, why? Wire is wire. And I had to laugh because it is kind of a weird saying in our industry. You would think if it's metal, aluminum, things like that, you would think what can you do to modernize that, make it advanced? But I have to admit, I've been impressed with where our advanced conductors have come, how far along they've come. We started doing it because of the need to push more into the existing rights of way. Obviously, as we get more and more toward a digital terrain line models or digital transmission line models, we're going to find more and more constraints on our system related to SAG, whether that be SAG clearance violation to the ground or clearance violation to other things going under, whether it be buildings or distribution that's under it. Then we're going to have to find ways to mitigate that fairly rapidly. And so we started looking at different things, and we started looking at ACCC, particularly several years ago, about the same time that 3M was coming out with it too. But they were all about cost and property and additional ampacity. And one thing that I thought was kind of unique about CTC is their warranty. They actually had an up and down warranty, so they were putting their money where their mouth was related to that. And fortunately, we've never had to use their warranty, so I'll take that as a brownie point for them. So you can go to the next slide, please. So a little bit of history. We began looking at advanced conductors in 2004, 2005, and started really looking specifically at the ACCC product and the 3M product, ACCR. And typically, as utilities do, we went and reviewed all the available testing that had been done and developed. And we also went and started doing our own testing. We have an internal lab that we've done some like vibration testing and mechanical strength testing and stuff on, but we also utilize Kinectrics in Canada and Toronto to do some testing for us that we basically submitted to them. And obviously EPRI has done quite a bit of stuff on it too. So that was our way to try to get comfortable with even looking at the technology and doing it. And then obviously we did a lot of engagement. We started poking around with other utilities that may have been using it at the time. And then we started a collaboration with CTC, and that's basically, Dave, I think that's when I first met you is in Irvine when we came to go visit your plant there, and was impressed with that. And then, so you can move to the next slide, please.
I'll just jump in there real quick. You said one word, James, that was pretty important. You said distribution. And so you might comment as we go, and even Devon, you might comment as well about the applications for distribution if your utilities have started to think about that. And then I also will say, Dave Bryant, James is talking about that process of collaboration. Do you want to interject anything about how you guys at CTC Global were working with AEP at that time on that process of collaboration or partnership?
Yeah, thanks, Mike. We were all ears. We wanted to do the best job we could of understanding the challenges that AEP faced and their installation crews. We wanted to, the collaboration to us was amazing. In fact, their efforts to help us understand these things led us to actually getting our plant certified, ISO certified. So there's a lot of great collaboration and learning that went on, from on both sides that was really great. And the relationships that we developed were also personally very satisfying for me.
Yeah, and I have to laugh, because we developed a lot of testing done with Conductors, and I used to tell people that I think that the ACCC product is probably the most tested conductor that I've ever been involved with. So there's quite a bit of that going on. So,
but to your credit, you guys at AEP did innovate, and a lot of people talk about innovation, and you guys have definitely done the innovation.
So I thought I might do is talk about a couple of projects. We've done many, but let me talk about a couple, and that being the first one, and one really big one that I've been proud to be involved with. And so our first project, and I'll call it a pilot for lack of any other word, was a 138 kV transmission line that we had in the Texas area around San Antonio. It's actually in Pleasanton, Texas. And so it was basically an older line. It was wood H-frame structures that was there. There's 139 of them. It was actually a tie line with city of San Antonio. That they had half the line and we had the other half. Our portion was 15.7 miles. And we wanted to try this technology, and that happened to be a perfect example for us to use. And so we were replacing a Partridge type conductor, an ACSR type conductor. And the conventional choice we would have normally made was just basically going and replacing most of the structures, if not all of them, going back with a larger size conductor that would support it. And so that extra steel that you're going to put in the ground and actual time that it takes to get it done was what you worry about. And so the graph on the lower left is just depicting what the typical span lengths are for that particular line. And then there's a couple of graphics there that show the typical transmission structures that we were dealing with on that one. Next slide, please. So what we decided to do on this was keep the existing structures and then utilize the ACCC's Drake equivalent that they use. And doing that allowed us to be a lot faster at getting it done. And we estimated a cost savings of over $600,000 just on that particular line. We in-serviced it in 2006. And if you want to know more about this, there's actually a T&D World article that we submitted in the July 2006 timeframe. It did have some challenges, and we learned a lot from this particular project that allowed us to really get more comfortable with the ACCC product and using it in other types of projects going forward. So with that, I want to really talk about a really large project that I was involved in and very proud to be involved in. So, and that is some reconductoring of 2 345 transmission lines that we have going to the Valley of Texas, the lower Rio Grande Valley. Obviously, you've been hearing about LRGV a lot, and not for those good reasons these days, but this was a good reason. But that area in Texas, that lower half portion of Texas for us, has always been a very large, high growth rate area. A lot of snowbirds coming into that area, a lot of what they call the mirror companies across the border that are there. So it's always been a high growth rate. And so traditionally, the way ERCOT works in Texas is they don't give a lot of price signals to get generation to locate close to the loads. They're locating closer to the fuel sources for the most part. And so in this particular area of Texas too, we don't have, at the time was generation deficient. And so the bulk of the load was being served by the 2 345 lines you see there in red coming from the Corpus Christi area, where there is sufficient generation going down into that lower Rio Grande Valley area. So a couple of statistics there. The peak load had been increasing by about 80%, and this was 2011. So for the last 10 years, basically, it had been increasing by about 8%. It's traditionally a winter peaking area. And so it doesn't really get that cold down there, but everything is all electric. So it's 99% all electric for the most part. And so the record in 2010 was 2,378 megawatts. It was predicted to grow about another 3,000 megawatts in less than 10 years. So that go to the next one, please. So we actually had an event, a weather event, that caused us to have to react to making changes down that area pretty quick. So the winter of 2011, from February the 2nd through the 5th, temperatures dropped to freezing. So for you folks that live in the Great White North, freezing doesn't seem like much, but in that part of South Texas, where you have a lot of, I'll say, RVs and stuff that are all, they're all electrical loads. It basically, we got a 500 megawatt increase. That was in just that one period of time, and it exceeded the 2011 summer peak by 500 megawatts. So it was a wake up call for us. We actually had to have to do load shedding and have rolling blackouts just to maintain stability in that part of the world. So that was a wake up call. So we had to do something pretty quick, and we had to do it within the constraints of the outage constraints that we have in that area. So if you go to the next slide, please. So as I mentioned before, like I said, there was no way we were going to get both those 345 lines out in order to do a typical type of reconductor project that we would normally do. So we decided to go back with an actual energized reconductor. So we reconductored both those lines, those 120-mile lines, while the lines stayed energized. We basically took one-shot type of clearances, and we did that over time. We decided to keep the existing tubular H-frame structures. We had to do some work. I mean, we had to replace some of the braces and stuff like that, but for most part, we kept all of those. And we replaced the 2-conductor vertical bundled 795 ACSR with an equivalent of the ACCC, which is the Drake. So in essence, if you add up the vertical bundle plus the 3 phases times the 120 miles, we installed 1,440 conductor miles of ACCC basically in one project. And by doing that, we were able to increase the summer peak rating by about 75%. So that's a pretty dramatic increase. And it actually bought us time to build a couple of other 345 sources into that lower Green River Valley. And we're still in process of adding another transmission line down that way as we speak today. The added benefit of the ACCC too is, if you remember the map that I was showing earlier, it does follow the coastline, the Gulf coastline. And so that is susceptible to corrosion from salt area environment. And so the ACCC was actually a little bit more resistant to corrosion for us, and so it allowed us. So both of these projects have been in service since then. We have not had any issues whatsoever with them beyond your maintenance type of stuff going on. Next slide, please. So
hey, James, I'll comment. You made that comment about freezing temperatures in the lower Rio Grande Valley. We had a question from the audience about how this conductor with the composite core responds in freezing temperatures. So audience, thanks for the questions. We appreciate that. We see them coming in, and we're getting ready to answer them towards the last part of this webinar. But James, just comment on that. Have you done anything beyond the desert Southwest or South Texas up into some of the other colder regions of your service territory?
Yeah, so in this particular area, the first one that we did was the NESC NESC medium ice loading. Obviously, this one is in the light, but from an AEP perspective, we're always more conservative, so we always go up to the next one. And so we've installed several installations in Arkansas, in the mountains in Arkansas and stuff like that too. So we do some in the heavy ice loading zone. And I think we're doing it with the standard conductor, because I don't believe that we've installed any of the ACCC ice specific conductors. So yes, we've done some, but not a whole lot.
Okay, so you really don't have experience yet in a heavy ice environment or a sub-freezing environment with the. I mean, Dave, Bryant, do you want to comment on that real quick, and how this conductor, how the core responds in freezing temperatures?
Sure. It's carbon fiber composites are widely deployed for cryogenic storage containers, so way below zero. We've done installations in a lot of cold climates. I think a point that's a little bit more important to point out is that The carbon fiber composite is fully elastic. It will not yield or plastically deform. And while that can cause additional sag under extreme ice load convents, the nice thing is that after the ice load has been shedded, the core goes back to its original length. So you don't get this excessive creep or yielding that can happen to a steel core conductor. The other thing that we've done over time to support our customer needs is we've developed a higher modulus, higher strength core that's better at resisting or sagging under heavy or extreme ice load events. And we also have an aluminum zirconium alloy that can be used also to further support those types of extreme situations. Thanks.
Thanks, Dave. Back to you, James.
Yeah, and I might finish up here with a couple of things here. So we completed all this work in March of 2016 and got both of them energized and buttoned up. And if you want to know more about these, there's a couple of T&D work articles that we published in May of 2013 and another one in September of 2016. And the thing I'm really most proud of is we submitted this for an EEI Edison Award. We did indeed win that in 2016, so that was pretty exciting for us. And so it wasn't just the use of the advanced conductor, but it was the whole energized reconductoring process that we went through that was unique about it. Next one, please.
Yeah, congratulations on that Edison Award.
Thank you. So at the time that we completed this, I mean, there are some estimated things that added to the benefit that we had about, you know, the clearances and that type of thing. So obviously we can benefit to it of reducing line losses that we had, and replace some of the CO2. And these days, that's a lot more important than it seemed like it was in 2016. And it will become a lot more important as we go forward with the climate change initiatives that are going on. So these are just additional benefits that are probably taking on a lot more in the decision-making process at this point. Next one, please. So I just want to kind of finish up and give you a little bit of how much AEP has installed for advanced conductors. And at the various voltages, one thing I didn't do was go down and tell you the types of conductors we use, but I think for the most part, we were using the Drake equivalent on the ACCC side. But we have basically, if you look at the line miles and conductor miles, I think it's over 3,000 miles or pretty close to it. So we have gotten pretty comfortable with using it. And so really it just becomes a matter of making sure that our T-line engineers, when they are looking at projects, that they kind of include that in the analysis to use on reconductors. So with that, I'm going to turn it back to you, Mike.
Well, that's very interesting, James. I appreciate that. We might come back during the questions to say, what kind of analysis do those transmission line engineers go through? Do you have a set process? Because you've got, what, 3 different offices, one in Texas, one in Columbus, and one in Roanoke, and do they all do it the same way? And we might come back and visit that after we hear from Devon Kendall at NV Energy. Devon, you're doing some really exciting things at NV Energy, and we're looking forward to hearing from you. Take it away, Devon.
All right, thanks, Mike. Hard to follow up on James. That's a lot of really cool stuff that they've been doing over there at AEP. So NV Energy is, we serve Nevada, and we kind of have 2 major service territories. We have Las Vegas, which you think of the Strip, high energy load. It gets to 120 in the summer, so it gets hot, using lots of air conditioners, lots of lights, and there's a lot of rapid growth in Las Vegas. Over the last 20 years, you know, it's doubled, almost tripled in size. The system there is really robust. We have 1,400 transmission miles at various voltages, but it is a booming metropolis and growing and growing and growing. There in Las Vegas, where we use ACCC, is a focus on reconductoring. We have older lines that don't have capacity anymore, and we're seeing electrification throughout the valley, so we need to increase capacity of the lines. Northern Nevada is kind of still the wild, wild west. We have Reno as the biggest city in Northern Nevada, and that's where I'm located. But the rest of the state, so the northern half of the state, is still mining load, industrial load. It's, you know, these rural communities out in the middle of Nevada that need service and are increasing their load, as well as we get more renewables onto the system and more generation in that way. So what we look at when we're focusing on reconductoring is these radial loads in northern Nevada and how we can increase ampacity on those single lines. We have been using it in northern Nevada as we've gotten data centers onto our system as new line builds, so that we can get higher capacity out of our lines. Our crews, our internal crews, prefer working with ACCC to a bundled configuration. And so we've standardized on ACCC, and we love using it. As James said, there are gigawatts of data centers coming onto our system as well. And it's kind of an arms race for data centers. And that's kind of the future that we're seeing, is that we need to have high capacity for data centers. ACCC really meets those needs. We are building a large 525 transmission loop throughout Nevada, connecting Las Vegas, Reno, and Ely, which is the eastern side of the state. And that will, as part of that analysis, we are looking at ACCC, seeing if we can use it on that to have high capacity, so that when we get renewable generation throughout the state of Nevada, we can add that on quickly and not have to worry about capacity constraints on the system. In the Tahoe Basin, which is part of our service territory in the western part of the state, Tahoe is very resistant to growth. And so they look at keeping structure heights low. They don't want tall structures. They don't want visible structures. And so we have to go in with reconductors there in order to keep our structures low, keep our sag low, and really thread the needle through the Tahoe Basin. So we kind of have a really good mix of what we're using this ACCC for. We use it under NESC light loading or NESC medium loading and NESC heavy loading. So we've seen it all. Next slide, please. So our experience with ACCC Conductor is kind of two stories as well. We've standardized on 431 Lynette, 1026 Drake, and 1949 Lapwing. We have in-stock reels at our warehouse. We have in-stock hardware at our warehouses, and we are looking at projects constantly for using ACCC. In Las Vegas, we have 58 line miles with 4 lines, and we have 4 planned projects there. Like I said, a lot of that is within the valley. It's increasing these lines that need just a little bit more capacity and reconductoring those. In Reno, we have 70 line miles on 21 lines and 14 planned projects. So we are planning on keeping using this ACCC. Personally, I've designed 6 projects with Drake and Lapwing in Reno when I was a transmission engineer. Now I'm the manager, so I don't get to do that as much. We have nothing on distribution yet, but I will say our executive teams know the success of ACCC. So I wouldn't be surprised to see it start going towards distribution in the future, because they know how successful it has been for us. Next slide, please. So this 107 line reconductor, this was our first project in Nevada. This was 2009. It's Reno to Carson City, and it was a capacity increase. The big thing on this one is we didn't want to replace structures. This line goes through golf course, backyards, and it's through Reno and Carson, and we wanted to avoid the extensive permitting that happens with projects of this kind for a rebuild. 17 miles of line through communities. The communities are not going to want larger structures, anything like that. So we went in and reconductored with the 431 Lynette, and it's been a very good line for us. In 2012, 3 years after it was installed, the line experienced a wildfire in the area. And that's a threat that we have throughout our system is wildfire threat. The line dropped on the ground. Our crews went out there and they inspected it. and they were able to reinstall it on the structures again. And we've had no problems with it. So one thing you hear with ACCC, these advanced conductors, is that you have to be careful in handling it. Yet we've had these experiences where it should have been damaged and it should have been replaced, but we were able to check it out, make sure it was good, and it was good, and it still performs well. All right, next slide, please.
Hey, Devon, let me interject a question here. We just had a question from the audience, and they asked about the decision-making process that you go through when you decide to do a reconductoring with ACCC. And I'd like you to answer that. Loved your comment about the avoidance of the need to permit when you're doing reconductoring. But you also made a comment that your executives are aware of this and they're aware of the successes that you've had to date. And then I also want to comment that you guys are a Berkshire Hathaway company. So you're a privately held utility. And does that have a different dynamic in the evaluation of this? So what kind of criteria are you using? You got the executive visibility, you're a Berkshire Hathaway company. What all goes into that process of deciding what are those next lines that are going to go ACCC?
So like you said, it's Berkshire Hathaway. So even though we are privately held, it's Berkshire Hathaway. So we are privately penny pinched. And so we need to make sure that it is a financially sound decision for our company. The big thing with Reconductor is you decrease your costs by not having to replace structures. It's just plain and simple. The conductor, yes, is higher cost than your traditional conductors, but you decrease that cost. We have found on new line rebuilds as well, where we need that high capacity, that we are not spending as much on labor. Otherwise, we would go to a bundled configuration where we would need to, our crews would be out there longer, our construction crews would be out there longer, and they would be spending more money in construction costs. So we've kind of done the economic analysis, and we've found that reconductoring makes sense financially. And then we've also found new line builds, because of the increased capacity, because of the less time in construction, faster installation, we have found that it is a financially viable solution for us. When we're going through our conductor selection process and our reconductoring process, that kind of funnels through our transmission planning groups, and they give a recommendation. They say, oh, we need to increase capacity on these lines, and we look at it and we say, we usually, as the transmission engineers, give a recommendation of, most of the time it's ACCC, because we're familiar with it, we're happy with it. Like I said, our executives know the success of it, and so when they're going out and meeting with these large developers, these large data centers, they're saying, hey, we've had success in this industrial area with using these high capacity conductors, and we can get you the loads that you need. And so they're confident in it. And so it kind of works as a sales pitch to those data centers, so they're more enticed to come to Nevada, and that's why we're seeing more and more growth. And so it's kind of a snowball effect using this ACCC.
That's good. And you touched briefly on your crew's acceptance to the tools and the hardware, et cetera, et cetera. So is there any special training that you guys have had to do? This is a question from the audience. Any new hardware? It sounds like you've got a lot of the tools and equipment and the hardware in your warehouse as well. Can you comment on that?
Yeah. So our crews have had extensive training. CTC offers that training, and it's been great working with them. Every project that we have, they call us up, they say, hey, we see this coming on the radar. What kind of training do you need? Is this a new contractor? Is this, who is this? And so we work pretty closely with CTC on that training. And they'll come out and spend weeks with the crews, make sure they're doing it right, make sure that they're following all the procedures, all the handling instructions. One big thing is you just don't drag it on the ground, you don't hang it over in the rollers. So it's a little bit different than your ACSRs or AAs. Our crews have all the tooling. They learned how to use all the tooling, and they know what works. And like I said, CTC has been like this really great working relationship to have, or they'll fly up, we'll say, hey, we need training. They're there next day after, and making sure that we're getting the training we need and working through our problems. It's just an easy phone call for us, and they're right on it. So that's what our training experience has been like.
Hey,
Yeah,
Mike, I'll add to that too. So it is pretty important that the crews know how to do the splices and dead ends. And I have to agree that, it's pre-annealed aluminum that's on it too, so you don't want to scratch it up because it'll get corona and stuff like that on it. And then the most critical thing is when you're pulling it, make sure that the dollies are of sufficient radius to do that with, because those are the main points for it. But other than that, it's, handle it like you do ACSS and other high temperature stuff. And I have to agree, CTC, I mean, they were right there with us too. They'll put somebody on the job site and work with the crews as long as needed, kind of thing. And that was critically important.
Yeah, that's high praise, Dave Bryant, coming from a couple of great utility clients that you've got. That I wanted to just get your comment on that too. It's a collaborative effort. You, Dave, have been in this business for a long, long time. Comment on your ability and to go out there and give the training to the line crews in particular, if you would, please.
Sure. We've got, last time I checked, we had 82 master installers worldwide, and those guys are working 24/7 somewhere. As I mentioned, I think we've got 80 ongoing projects. So we take that support very seriously. It really, at the end of the day, there's not much difference other than what was just mentioned. Mike and James mentioned that we use travelers that are sufficient, and you want to respect bending radiuses. But I think it's noteworthy to point out that the hardware that we've designed using the Call-It system that is really compatible with advanced conductor cores. So that's a key solution, and it really only takes a couple of crescent wrenches to install. But it's important. We'd like to have our guys in the field to support our customers to face whatever challenge they've got. Sometimes pulling angles or nuts or going over mountain crossings are crazy. So we like to give them whatever support they need.
Good. Thank you for those comments, gentlemen. Devon, back to you.
All right, so this is the 128 line Reconductor. This is a Reconductor job that we did here in Reno. It was my first engineering job. As a young engineer, I had no idea what was going on in transmission lines, and the principal engineer said, here you go, you get this Reconductor. I learned a lot through this job, and it really solidified my experience with ACCC. The cool thing about this job is that we only had a stick model of the line. We went and got LiDAR, we got tensions, and we were able to calculate the tensions in the line, but we didn't have record drawings of the existing steel poles. As you know, record keeping is sometimes hit or miss. And so I modeled the line to play with the tensions and make sure that there was no increase in the ground line moment, axial shear loads, and we were able to just say, okay, we don't know what the capacity of the steel poles is, but we're not increasing the capacity with this Reconductor. And the low sag window that ACCC has really made it effective in doing that. So even when you don't have records, you can go in and really make sure that you're okay. Next slide, please, Mike. All right, and then so this is our experience. This is our kind of lessons learned. So like I said, you do have to be a little more careful with it. We did find out that T-taps on short spans, we had about a 60-foot span. You already got it compressed at both ends, and then you compress it in the middle with a T-tap to do a drop. That can lead to bird caging, and so you have to be careful with it. You have to let all that tension out. And so, but CTC, when we did that, we ruined like 3 spans of conductor. We just kept on doing it the same way and not having any help. We reached out to CTC. They walked us through the process that we needed to do for that T-tap. And now we have our crews know the proper way to do it. And it's not beating it with 2x4s, it's actually compressing it the right way. One other thing that we found is you can pull this conductor tight. It has a high tensile capacity. And so we have found that our insulators then become our limiting factor on our dead ends. And so we have to work with our manufacturers to make sure that we have high capacity dead ends as well. Like I said, I've said it several times, training with CTC is great. They've had us at their factory several times to inspect the factory. The cool thing about CTC is they're always innovating. That's what we see, is they aren't standing still on just what they have right now. They're going forward. They're adding the info core. They're looking at the call-in housing. They're looking at the dead end assemblies so that they can improve their product and we can have a better installation. They aren't just saying, okay, we're done. And so that's something that we've really liked about working with CTC. Also, so I talked about our executives knowing that this is a successful installation. You also have to temper your executive expectations. So sometimes they say, oh, there's no ACCC on that line. Well, sometimes the limit can then be the substation equipment. So yes, it is a good solution. You just have to make sure your system can support it. And like I said, our internal crews, at first, with all crews, they are against any change. They're very change resistant. But now they prefer ACCC to a bundled configuration. They can do it faster. They don't have to deal with twisting wires. They only have to do one roller on each structure, and so they love the ACCC and they work with it a lot. And so they're used to it, and our contractors are used to it, and that's something that we've found is we've gotten really used to it and happy with it. Now this line right here in this picture. This was a new line build. So this is 120 kV, about a 10-mile loop around our industrial center, making sure we have the capacity to serve data center needs. And so that's something that we do. And I'll give it back to you, Mike.
Devon, that's a great presentation. A couple of things that really stand out to me is number one, your crews now prefer these advanced conductors to bundled configurations. That's one thing, because that takes a lot of work and a lot of effort on your part, with some support obviously from CTC Global, but on your part and the men and women that work for you. That's pretty cool stuff. The other thing that was kind of funny, a little bit ironic, is that now the substation equipment becomes a limiting factor on our transmission lines. Like we can give you more capacity on this line, substation engineer, if you will upgrade or give us a larger equipment with more capacity. And then the other thing is that this is a new line. You are now doing this on new line construction, that you have so much confidence that it's not just for reconductoring, it's for new line construction that gives you that add capacity that you're going to need down the road, that you maybe don't even know that you're going to need down the road. But as you've probably proven on the NV Energy system and AEP systems, is that you always appreciate that extra capacity on those lines, on those cold winter peaking days down in the lower Rio Grande Valley and such. So anyway, gentlemen, that was a great presentation. Let's move on to some Q&A probably here as we go to the next slide and see what do we really want to talk about. I think the three of us may just say, okay, what's the future hold for advanced conductors? I think we've touched on it all already, that that there are these international adoptions, that many utilities are starting to use this advanced conductor, this composite core conductor. Maybe some standards are going to develop. And James, I'm going to come to you here shortly and ask you a question about your design processes among those offices. I've kind of alluded to that earlier, but if you guys want to talk about what the future holds, if you each just want to volunteer something here, we'll start with you, Dave Bryant, and then James, and then Devon, and then we'll come back and get to some of the many questions we have from the audience. But Dave, what's the future hold as we look at this particular slide?
Well, thanks for everybody's comments. Devon mentioned that we're not standing still with our development. There's always we're always working to raise the bar and better understand utility challenges as they evolve. It's a very dynamic time in our industry. I think we're seeing, at least from my desk, I'm seeing a lot more selection of ACCC conductor for new lines. And that's part of it is because they really want the efficiency, or they've got environmental challenges that they want to stay ahead of. But it's also, we're seeing the term future proofing come into play. So there's like, again, as I mentioned, we didn't envision data centers as being as substantial as they are 10 years ago, but I think new lines are sort of going to be more embraced. Thanks.
Yeah, I'm intrigued by that. We're going to come back and talk a little bit about your plant capacity and your ability to respond to these markets too. And James, go ahead and give us a couple of comments about what you think of the future of advanced conductors is going to be specific to the AEP system.
Well, I mean, advanced conductors for us is just another tool in the toolbox that obviously we need to utilize. And I want to kind of touch on the point that you said. We have 3 major engineering offices. There's Tulsa, Oklahoma, and New Albany, Ohio, which is right outside of Columbus, and then Roanoke, Virginia. And we do have, like most utilities, have a good set of standards about, here's how we should tension in a conductor, and here's how we should do all this type of thing. But when it really boils down to it, planning tells us what capacity they need in a line, then our T-line engineer will choose the conductor to match that. And unfortunately, or fortunately, whichever you want to look at, unfortunately, they tend to fall back on what did they use last time, and that tends to be what they start working with. But we are trying more and more to keep them looking at alternatives to that will help us future-proof it, as you were saying, because today, from a prudency viewpoint, we can only build based upon what we know at this time, and we don't know what that next data center is going to be at 400 megawatts that hasn't signed anything yet. And so typically, I have to agree with that as we start, making our structures such that they could be you can replace the conductor and actually get something more throughput to it. Is going to be critical to where we're heading.
Yeah. Devon, comment, you said this, and now we look at it in the slide, we see this ACC info core system and the possibility of embedded optical fibers in this conductor. Is that something that NV Energy is looking at in the future, and how do you view advanced conductors in your future?
Yeah, so the info core we are really excited about because it gives us the ability to put the contractor, make sure the contractor handles the conductor correctly. So we've started to spec it out in all of our new line builds, and we put it on the contractor. Hey, we will order it. We'll get the conductor to us, and then you have to inspect it, make sure blast that light through the info core system, make sure the core is intact, and then you are responsible for it. So it's kind of our handoff. It's a QA QC. It makes a lot of sense. It is easy to do. It's easy to check, and hey, that gives everybody confidence that the core is intact. And that
okay, so this optical fiber is for the purposes of a pre-construction and post-construction inspection.
Yeah, currently pre-construction. I know CTC is working on post-construction, but we aren't. I mean, we don't need we already have the OPGW, so we don't need the fibers for telecommunications. We need it for inspections.
Okay, that's interesting. I wonder if it might serve both purposes at some point in the future. I bet you people are thinking about that. But okay, well, we have time now for some audience questions. We've been answering some of your questions as we've been going through this. Gentlemen, you've done a great job in addressing these questions. That last question, Devon, was actually a question from the audience, and I'll let James comment on this as well about pre-construction and post-construction inspection, or how you inspect this conductor differently than you do like an ACSR or something like that. James, you want to comment on that?
Yeah, so I'd say at this point we really don't do any difference we don't use the fiber one that I'm aware of, but so basically it's just a physical inspection to make sure that the splices are done as appropriate. And then beyond that, once it gets energized, make sure that the electrons are flowing. So that's pretty much what we're doing. So we're not really doing anything different, I guess, for this that we would do for any other conductor.
Okay. Here's an interesting question, and it has to do with galloping. Do you have, I would imagine at NV Energy, you guys have some examples of galloping on the system someplace on your EHV, but even at AEP. Devon, do you have any experience with this conductor galloping at all?
We actually don't have much experience with galloping in Nevada. It's a mountainous terrain, so the laminar flows that you need for galloping don't really happen. So it's a good thing, I guess, we haven't had much experience with it.
Okay.
But, maybe James, maybe you have.
James, and then Dave, if you've got to comment. But James, what do you think about galloping on this conductor?
Well, we do have galloping throughout our system, obviously, but I have not heard of any issues with ACCC specifically under galloping conditions. I was actually going to ask Devon, you made a comment about, pulling the tensions a little bit higher. Are you worried at all about vibration?
No, I don't think we're really worried about vibration. We use typical dog bone dampers, and then ACCC, it has some self-damping characteristics, so that's helpful as well.
Agreed.
So I'll
Dave, yeah, go ahead.
So my good friend Eric Engdahl and Bruce Freimark at AEP developed a sequential mechanical test that was performed at Kinetric's lab, where they took a conductor, ACCC Drake-sized conductor, they ran it through a shiv wheel, 50 times back and forth to replicate the installation stress. Then they installed it on, I think it was a 215-foot span with a suspension clamp located at 1/3 of the span. This is a test developed for testing OPGW. They ran 100 million cycles of vibration, followed by 100,000 cycles of galloping. And they did that with ACSR, ACSS conductors. Then they pulled the conductor to failure. They took the remnants down to their lab in Dolan, Ohio, and did I think 22 different tests where they looked at bending. They did a whole bunch of other stuff to really kick the tires hard. But what we noticed is that the vibration and galloping caused damage on conventional ACSR, ACSS round wire conductors, but the ACCC advantage was with the smooth single composite core, coupled with the smooth surface trapezoidal strands, help dissipate energy at a factor of about 10 times better than a round wire conductor, and that also comes from other test data. So the tires have been really kicked in. I know that some utilities have challenges with galloping. This is a T2 has been one solution to that. We've been very successful in installing ACCC conductor in places that are susceptible to galloping. One in particular, and I'll try to keep this short here. In Kansas, they did an installation and on a new line with Class 1 wood poles. It was a 21 or 22 circle mile connection to the city of Kingman, Kansas. They experienced galloping. The conductor did gallop, but cross arms broke, but the conductor wasn't damaged. So they selected it then additionally for FEMA repair jobs for other lines that had gone down. So we've had pretty good luck with galloping resistance. And again, as I mentioned, cyclic load fatigue improvements.
I was always impressed you could get past the Bruce and Eric tests.
Here's a question from the audience about the length of the transmission line. So is the length of a transmission line using these advanced core conductors, is that a limiting factor in any way?
Who would you like to ask?
Yeah, I'd say Dave. I'd say Dave is what's your experience with that?
Okay, so what we found is that, and if you go back and look at, gosh, there's actually a really cool report, and I'm going to see if I can remember the name of it. It was recently published it's a working paper, so it's still a documented process by Haas Berkeley lab. They've got something that if you guys are interested, I can get you a link to that paper. But it talks about the benefits of ACCC conductor or advanced conductors over conventional HTLS conductors or other, but they're usually limited by or have issues with voltage stability and things like that. So often on a 200-mile line, it might be good to put in use other technologies to help stabilize voltage and address other issues. But I²R losses are usually up to about 100 miles.
Okay, so if you're going to go cross country on a major project, you might want to look at there might be some further analysis that your planners and engineers might want to make on advanced conductors.
What type of devices do they need to add, or are they going to flip it to DC? We've done a pretty substantial DC project in China, 1100 kV project.
Oh, that's interesting. That's interesting. Okay, James, this question is going to come to you, and Devon, then we'll follow with you. But James, you mentioned that you had to make some adjustments after the first installation of this conductor. What were the adjustments that you had to make, and how does the operation differ from typical ACSR for grid operations, like precautions, limits, and other standard operating procedures? And that kind of goes along with what are the do's and don'ts of an ACC install versus a typical ACSR. So I'll give you that, James, first, and then Devon will come to you and ask, the do's and don'ts of ACC versus ACSR, and what types of things that you've learned from your first installation till now.
Yeah, so I kind of alluded to our first installation did have some challenges. We actually dropped the conductor several times during construction. And so that's when we got the CTC folks involved, and we did a forensics on it. And what we concluded was it was installation error. And basically they were pulling it through the dollies that were too much, not enough diameter. They got it wrapped into some bull wheels and all kinds of things like that. And once we got CTC engaged and got them basically to do training with that, then it kind of resolved all those problems. And we haven't had any other installation issues that I'm aware of on any other project since then. So that's what kind of a plug for that. And now I'm trying to remember what the follow-up question was, that Mike.
Well, any differences between ACSR operation versus ACC operation? Okay, you've got it, it's installed, it's been there 5 years. Does system ops even know there's a difference between the conductors?
No, once we give them a rating in system ops, they're basically operating to that rating that we give them from a transmission line perspective. But as like I said, we don't do anything different related to that conductor being installed inspection-wise, maintenance-wise, or any other thing like that since it's been put in.
Okay, Devon, do you want to comment on that?
Yeah, kind of same as James. I think we had a few hiccups on our first installation, but then since then our crews have gotten used to it. They know how to handle it properly. CTC is always available for help if we need it, and so they're very efficient at operating with it, at installing it. Now we know those limits, like, hey, when we're doing our design, you have high tension on your ACCC, so check your dead ends, check this, and so we have part of our design checklist, a few items to check with ACCC.
Yeah.
As far as operations go, right now FERC 881 is on the horizon, and using dynamic line ratings. I'm sure ACCC will help that, and it will be a way, like James said, we just give our operators a limiting factor on this line and let them go. But as we look at FERC 881, I'm sure that these advanced conductors will help us in operating the system.
Yeah, I actually tend to agree.
I was going to mention that we really haven't gone back, and we probably should go back and do a study to say how many of those installations do we have that we actually approached the thermal rating on. I would imagine we've had a few, but I don't have any metrics to tell you whether or not. And obviously, we haven't had any issues with the conductor itself, but I don't know how many of them we've really pushed to the limit.
Actually, that answers a question that just came in, James. So your timing was good with that. Dave, Bryant, I want to come over to you. I want to ask you about plant capacity for this, both domestic. You said you're opening up a new plant in India. What's the lead time? And this is a question from the audience about lead times and your capacity here, even domestically, for sourcing. It says, can you source hundreds of miles from U.S. plants? In other words, if they had a multiple hundreds of miles of transmission that they needed to source, can you source that domestically, or does that come from plants around the world?
That's a good question, and I don't think that I can answer it exactly. I can comment that we have a tremendous capacity here in Irvine, that all of the other plants have been certified to the same level with the same technology, same equipment, same training, and a lot of people cross-pollinate from one building to the next. So there's a good collaboration amongst all the different manufacturing facilities. We'd have to look at the capacity of any of our 35 manufacturing partners. So we usually try to get the information to them ahead of time so that they too can also plan to make the finished conductor. Our core capacity is pretty substantial.
Right. We've talked about operations and maintenance. We talked about construction. James and Devon, I want to talk about the design process a little bit. So there's a question from the audience about IEEE standards. Are there any IEEE standards that pertain to composite core or advanced technology conductors? And then, James, we've talked about the number of offices that you have. You obviously, Devon, have an office in Reno and one in Las Vegas. How do you coordinate amongst the young engineers that are doing that transmission line design so they know and understand how to design with these with advanced conductors? James, we'll start with you.
Well, I'm gonna comment. There's not that many old farts like me around anymore, so we're having the average experience level for T-line engineers since they're moving around in a high commodity item right now, it seems like it's about 5 years or less. But obviously, we have a strong standards department. They're the ones that have all the experience, and those are the ones that we really refer to make sure that our standards really give us all that we need to train our young engineers coming in through a robust training program that we've been creating internally. And so, as far as IEEE standards, I know there's a couple of things out there, but that's not really in my area of expertise. So we require our standards folks to really know that and be the subject matter experts on it.
Are you finding that your consultants that are designing your lines, are they up to speed on this as well?
I think for the most part we use the big engineering consultants, so they do have a pretty breadth of experience as well. So I would think they are, and if they aren't, we're usually our standards, right? Because they're building it to our specs and our standards, so they should be familiar with those.
Right. Devon, do you want to comment on that design process?
Yeah, so a lot of that starts with, we have our principal engineer in Reno was the first engineer to work on the ACCC in Nevada. So he has the experience with it, and so he's, as the mentor to the rest of the group, has given that to everybody, including myself. When I was the young design engineer, I sat in his office. I remember my first day, I sat there and he has his cabinet there with 10 different wire samples. One of them's the old copper conductor that's hollow in the middle, and then he's got his ACCC, and he's like, all right, this is your first project. This is the wire you're going to be using. And so it's, in my point now, where I'm the manager, it's doing that same thing, and it's instilling into these young engineers, hey, this is what we're using now. This is the future, and they're getting on board real early. They're getting used to it, and they really like it. And we have 2 offices, one in Reno, one in Vegas. I'm the manager for both offices, so there's kind of ease with that. But in the future, if we ever split the group, then it will be, making sure that the principal engineers have familiarity with it and are comfortable with it, so that they give that to the young engineers as well.
Yeah, well said. I think young engineers in particular are very interested in doing things in this 21st century that were not necessarily from the 50s and the 60s and the 70s, but using the latest and greatest technology that we have out there. So it's an exciting time to be in the industry for sure. We have addressed most of your questions throughout this session. We appreciate the questions coming from the audience. I will say that let's take the last minute for each of our panelists to give some concluding remarks as we wrap up here. James Berger, we'll start with you from AEP, and Devon Kendall from NV Energy, and then we'll wrap up with Dave Bryant from CTC Global. But James, give us some concluding remarks. Exciting technology. You guys are using it very well at AEP. Appreciate the lessons learned that you've shared with us. Give us a concluding remark, if you would, please.
Yeah, sure. Like I mentioned earlier, this is not your grandfather's utility industry anymore. So it is exciting to see these types of technologies being used and really coming to the forefront a lot quicker than they used to in the past. I guess what's exciting for me going forward is to see how these advanced conductors work with other technology to really make that leap forward of where we need to get to in order to serve all of our customers. And that may be, for us, we put a plug in for our BOLD technology, our breakthrough overline line design that we have, that is, really for those long lines that we were talking about here too. But if you could combine that possibly with an advanced conductor, could that get you even more through there? So, and whether it be that technology or ice shedding technologies or whatever it is, it's going to be exciting to see that evolve over time. And so I'm looking forward to it. Thanks, Mike.
Well, James, I'm glad you mentioned BOLT, because I'm sitting here thinking about how innovative AEP has been, and you developed the first 765 kV system, big system in the country, and you've had that, and you've led the way on that EHV or even ultra high voltage transmission. And then you come up with this breakthrough overhead line design concept that was able to compact the designs and get more capacity out of existing rights of way. Yet you are still using composite core conductors and advanced conductors on your system as well. So you're innovating kind of across the spectrum of transmission and big transmission. So to the credit of AEP, that you guys have got a great culture there, and always appreciated in my career when I had a chance to work not only with you and some of your other contemporaries, but with AEP as an organization as well. So thanks for participating today. Devon Kendall. Yes, sir. Devon Kendall, some concluding remarks?
Yeah, I mean, as I've talked about, we've had great success, and with our executive team, they know that we've had great success with the ACCC. And one thing that they tell us is, hey, we're investing. Give us your best product. And so, like we said, we don't know a lot of the future, and so it's future proofing. And so we build in the best conductors that we can use, and ACCC is that. And that's why we're using it in our high industrial areas, our data center areas. And then obviously Reconductors, it just makes sense to do it financially, and it's easy to design with. It's really not a scary technology, and CTC, they're great to work with. So those are kind of my final remarks on this. Thanks for having me today.
Well, you did a great job, and you saw that James alluded to a couple of articles in T&D World Magazine. I guess I would certainly expect that to see some article in Energy Central coming down the road here from you guys, because you've done a lot of really good work at NV Energy. So congratulations, and you do have your work cut out for you in managing both in Reno and in Las Vegas. So good for you, and training up all those young men and women that want to follow in your footsteps. So. Dave Bryant, a lot of good things said about something you've been working on for a long time. So do you have any concluding remarks and comments for our audience?
Sure. Well, Mike, thanks. I want to thank you and James and Devon and Energy Central, and especially all the folks that have joined us on the call. We really appreciate your time and look forward to answering any questions offline that you have, if you have additional questions. I'm really excited about the future. This has been a kind of a challenging 20 years for me, but the payback has been amazing. And I'm really excited that utilities are looking beyond just mitigating sag and fractions and added capacity, but they're also looking at these technology solutions, including grid enhancing technologies, to really build a more robust grid so that we can face the challenges of the future that we can see, or some that we haven't even considered. So great effort by everybody, and I really appreciate your time.
Yeah, thanks, Dave. The challenges that we can see and the challenges that we know are coming in our industry as we talk about massive electrification, and we know that we're not going to be able to build the new transmission, and look forward in 5 or 10 years to even seeing this at distribution as well, which would be very interesting. So PJ Davis, back to you. Thank you very much, Energy Central, for the opportunity to do this webinar today. And PJ, back to you.
Thanks, Mike. Thanks, panel. Fantastic conversation today. Special thanks to CCC Global for making this event possible. For our audience, look for an email from us, probably sometime early next week, containing the link to the replay, PDF of the slides. And also, as you log off, please take a moment to complete our survey so that we can get your feedback. We really appreciate getting that from you to use in future sessions. From everyone here at Energy Central, thank you for joining us. We look forward to seeing you at an upcoming power session. Thank you for attending, and this does conclude today's presentation.